Hello again, I've returned, and in this video I will be explaining to you time dilation. The last video I did also delved into time dilation, but it mostly focused on E equals mc squared. This video is, as I stated before, primarily focused on time dilation. The next video, which will be the last in the series, will be on, well, you'll see. Last video I kind of explained time dilation a little bit, as it being what happens when you reach a certain speed, you begin experiencing time a lot slower than the rest of the universe. This video, I hoping to refine that point a bit and explain it in more detail. Anyway, enjoy. Okay, so, as I said before in my last video, a fast-moving object experiences time more slowly than a stationary one. For an example of this is if you were to travel 99.9999% the speed of light, then you will travel into the future in a very significant way. Because while at that speed, a second for you is just under 20 hours for Earth. So if you were to go for that speed for a day, then you would have been going for 86,400 seconds. Meaning that when you stop, you would have only aged that one day, but approximately 72,000 days would have gone by for everybody else. So, technically, you would have traveled 197 years into the future. Currently, this speed is unobtainable due to the lack of technology, but it is 100% possible. So as of now, the only time travelers are those traveling at high speeds above the planet. Let me explain. I am referring to the people on space stations, specifically the ISS. Two of the crew members that are on there are the twins Scott and Mark Kelly. Scott is exactly 6 minutes younger than his brother, but because he has spent 520 days in orbit moving at a faster speed than Mark, and Mark has only spent 54 days in space, Scott is actually now 5 extra milliseconds younger than Mark, meaning Kelly has traveled 5 milliseconds into the future from his perspective. Not a lot, but still counts. But still not much of a difference, so here's a different example using light from celestial bodies. Now, you probably heard the term light year before, especially if you were a Toy Story fan. So here's what that means. As you know, the speed of light is approximately 300,000 kilometers per second, and yes, I'm an American using metric units, sue me. As far as we know, that's about as fast as any object in the universe could possibly get to. And if you're wondering, if you make it to the speed of light, you will stop experiencing time altogether. So yeah, that's another reason. Anyway, moving on. To even reach the speed of light, you quite literally need an infinite supply of energy, because as an object with any sort of mass approaches the speed of light, its relative inertia and mass increases exponentially. Basically, the faster you go, the more energy is required to increase your speed. Objects without mass do not have this issue, because massless objects accelerate instantly. Okay, so back to the subject at hand, a light year. So a light year is actually pretty self-explanatory. It's this distance light can travel over the course of a year. Again, it's self-explanatory. Meaning that if an object moving at the speed of light were to travel 5 light years, the rest of the universe would only experience those 5 years. Of course, you wouldn't experience any time because you're moving at the speed of light. Meaning that whenever you look at a celestial body in the sky, you're actually looking into its past. Example, the star Polaris at the edge of the Little Dipper is approximately 323 light years away, meaning that as you look at it, you're looking 323 years into its past. If it were to explode right now, it would take 323 years for it to disappear from our night sky. Use an example a little closer to home. Let's look at the moon. It takes 1.3 seconds for light from the moon to reach Earth, meaning we're looking 1.3 seconds into its past. Cool, right? Anyway, that's about all I'm willing to animate at this time, so I hope I didn't completely butcher this extremely complex and intriguing subject that I no doubt didn't do justice, but I can hope I have piqued your interest and that you will pursue this topic in a greater way than I can explain. Goodbye, and never stop learning. I'll see you later.